Hey, good morning, everybody. Aloha Thursday. Hope you're doing well. We have a warm up today. Then today we have closure problems out of the book. Okay, and remember the closure problems, that means you're at the end of the chapter and you're getting ready for a test. So as soon as you're done with this warm up, get on that homework and give yourself a chance to try all the problems on your own so that if you don't understand anything, you have a chance to come ask your teacher for some help in their office hours this afternoon. Okay? That's what you want to do as a mature student. That's how you're learning how to become a student in sixth grade. And that's one of the things you always want to do. Remember, you can miss problems on a warm up or homework, but that's just part of the learning process, right? You can strike out at practice, does not hurt your team. You can miss shots at practice, it does not hurt your team. It's all preparation for the games or the tests. So it's okay to miss something on the homework. That's where you find out, oh, I'm not doing this right. I need to learn how to do this. And then hopefully you learn how to do it before the test, because if you miss a problem on a test, you lose points. Okay, so let's do our best to be honest with ourselves. And if we don't understand that, be brave. Okay, my Uncle James, my grandfather's brother, he was always smiling and he would never say goodbye. He would always tell me, he'd say, be brave. Okay, and when I learned about his life later on, when I got older, I enjoyed that saying even more. Okay, because when my grandfather was 13 years old, he had an older brother who was 16, and he had a younger brother, Uncle James, and 3 younger sisters. And his dad died. His dad was only 43 and died. And my grandfather had to quit quit school at 13 and go to work along with his older brother who was 16. So my grandfather at 13 quit school, started working to help support the family. But even that was not enough. And his 3 youngest siblings, 2 sisters and a brother, Uncle James, had to get sent like 1,000 miles away to an orphanage. And they stayed there for a couple of years until the family was able to afford them again. So he had a tough life, right? But he would always tell me, be brave. You got to be brave. Okay? You don't have to go live somewhere else. All you got to do is ask your teacher for help. Okay? I know it's a scary thing. It doesn't make sense that it's scary, but it is for your age. And then you do it a couple times and you feel more comfortable. And then all of a sudden you're learning and feeling good about things. Okay? That's the goal. All right. Enough preaching to you guys. Copy it down. Hopefully you can read my writing. This says recessed peanut butter cups are 40% chocolate, and the rest is peanut butter. We're pretending there's 2 ingredients, okay? What percent is peanut butter? Okay, and then what is the ratio of peanut butter to chocolate? And then there's a second part of a problem. Those are 2 questions, though, where I'm pretending they tried a new candy where they added raisins to the peanut butter cups. And the ratio they used for chocolate to peanut butter to raisins was 4 to 3 to 1. What's the ratio of just chocolate to raisins? Okay, so you got to think about those things, and I'm going to show you how easy that is. Then you're going to try to do the rest of these. When you're done writing the expression for how long that line segment is, then you're going to go to this where it says pretend like X is 3.2 and A is 1.3. Now, calculate how long the line is. Okay, we'll see in a bit. All right, we're back. All right, Logan, I'm going to get this one right. Yesterday, I missed that first time and just completely missed it. Okay, messed up all over. And Logan, thank you for calling me out. You got some Dean's List points for that, but I'm not giving you that opportunity today. You're going to have to earn your Dean's List points another way. 4200ths and 1 3/10. What 2 numbers work there? Here we're saying 7/10 and 6/10. Remember, when I add, I line up the decimal. I stack them one on top of another. The decimal comes straight down. 7 and 6 is 13. Okay, when I multiply, I pretend there's no decimal. 6 times 7 is 42. But in order to pretend this was a 7, I had to move the decimal over 1 spot to the right. In order to pretend this was a 6, I need to move the decimal 1 spot to the right. That's a total of 2 places I moved the decimal. I got to go back 2 in my answer. That's how we got that. Okay, 5 and 6/10, 7 and 8/10. Did I stump you? You're going to kick yourself. 7 and 8 tenths. Did I say 7 and 8 tenths, 7 and 8 tenths, 7 and 8 tenths, 7 and 8 tenths? Ooh, it's like the record stuck. And you have no idea what that means because you don't know what records are. All right. When I go add those, I have to stack them and line up the decimal. If there is no decimal, it lives hiding invisibly to the right of the whole number. Okay. Remember, $7 is the same as $7. I can add a decimal after a number. So I'm going to put the decimal after that 7 so I can make sure I line up these decimals. Now that looks weird because there's nothing over here. I can put a 0 after a decimal. Now I add them, and of course I get what I wanted to. Logan was hoping I didn't so he can call me out and get more Dean's List points, but sorry, Logan, I'm on it today. Okay, when you go multiply, you pretend there's no decimal. 7 times 8 is 56. And then I had to move this over one spot in my problem to make that a whole number in 8. So I have to go back one spot in my answer. That's how we got that. All right. Now, will this even work? 9 hundredths in one whole? I know 3 times 3 is 9, but 3 plus 3 is never going to be 1 or 10 or 8. So what are we doing here? Hopefully you figured out that 9 tenths and 1 tenth fit together to make one whole. And when I multiply 1 times 9, I moved it over once there, go back 2 spots. What do we say to do here? Fill in the egg carton. Boom. All right. How about the 2 and 6 1/3? Will that work? How about 6 1/3? Remember, multiplying fractions is, hopefully you yelled easy so loud your mom came running in from the other room to find out what you're yelling about. She thought there was a fire or something, right? All right. Multiplying fractions is easy because you go straight across the top, straight across the bottom. Now, there's no bottom here. Don't forget, any whole number, you can put a 1 under it. 6 is the same as 6 ones, right? Now I multiply straight across the top. 6 times 1, straight across the bottom, 1 times 3. And 6/3 just happens to be 2. Okay? Now, how do you see that? Let's see a picture of that. I got 2 pizzas, and I had to cut them into thirds so I could have 6 pieces and say I only ate 6 pieces, right? 1, 2, 3, 4, 5, 6 thirds is the same as 2 whole pizzas. All right, 12 1/5 plus 6 1/2. I can't add those. Those have different denominators. So I'm looking for a number that 5 and 2 both go into. Hopefully you said 10. That's the easiest one. I mean, they both go into 30 and 40 and 100, but 10's the easiest one, right? I did 2 times 5, so I got to go 1 times 5. I did 5 times 2, I got to go 1 times 2, and 2 tenths and 5 tenths is a total of 7 tenths, and 12 and 6 is 18. How about this one? 6 and 4/8, 1 and 2 tenths. Now, first off, I see I can simplify both of these. I'm going to simplify them first. I could just say what number do 8 and 10 both go into and go up to 40, or right? But this simplifies to 1/2, and this simplifies to 1/5. And now I can go to a smaller number and say 10. Now, I already know that 1/5 is 2 tenths. I'm working backwards, right? And 1/2 is 5 tenths. So I'm going to say 5 tenths minus 2 tenths is 3 tenths, and 6 minus 1 is 5. Kind of a weird question, huh? All right, simplify. Absolute value. How far is negative 4 and 2 tenths from 0? It is 4 and 2 tenths. How far is 3 and 6 tenths from 0? It is 3 and 6 tenths. So I'm going to subtract this from this, stack them, line up them decimals. I can't take 6 tenths away from 2 tenths. I got to go borrow. Now I can put a 1 there because 1 whole is 10 tenths. Okay, when we're using our decimal system, you can cross out and put the 1. That's why I added 10 tenths to the 2 tenths. That equals 12 tenths. A little shortcut. You didn't know how that shortcut worked till you started doing fractions, so, huh? 12 tenths minus 6 tenths is 6 tenths, and 3 minus 3 is 0. So this ends up being 0.6. All right, simplify 14 thirds. How do we do that? We divide the bottom into the top. How many times is 3 going to 14? 4 times, because 4 times 3 is 12. What do? My remainder goes on top. What was on the bottom when I started goes on the bottom. Now, do you remember how to go backwards from 4 2/3 to an improper fraction? If you do, you can double check your work, right? Here's what we do. It's called the C method. You make a backward C. Watch what I do here. I start at the bottom, and I go to the top. Okay, and I multiply and add. 3 times 4 is 12, plus 2 more is 14. That goes on top. What was on the bottom when I started goes on the bottom. Looks like we went back to where we started. I think we did it right. All right, last one. Line segment. I have x plus 2 plus x plus a. X plus 2 plus x plus x plus a. Don't forget that other x. Now, I'm going to put the things that go together. I have 3 x's. X plus x is the same as 3 times x. And 3x that means 3 times x. I'm going to put the letter next and the number last. Now, I could put 3x plus 2 plus 8 equals the same amount, but for some reason, they like the letters first. Okay? All right, so that's my expression. Okay? And now it says to go evaluate the expression for the values given. Now, where does it say that? It doesn't. I want you to know that's what you're doing. You're going to evaluate that expression, find the value of it for the values given. For x is 3.2 and a is 1.3. Now, what's the one word I use to tell you what to do there? Play soccer coach. Substitute. What does that mean? I'm going to substitute. If x equals 3.2, I'm going to put 3.2. Now, that's not going to give me 33.2. Remember that 3x means 3 times x. So I'm going to go 3 times 3.2 plus 1.3 plus 2. Now, this 3 times 3.2, let's give ourselves a little room. Pretend there's no decimal. 3 times 32 is 96. But really, that was 3.2. I had to move it over 1 spot to pretend there was no decimal. So I go back 1 spot. 9.6. So now I have 9.6 plus 1.3 plus 2. 9.6 and 1.3 is easy to line up because they both have 2 numbers, right? A 9 and a 6 and 1 and a 3. So when I write those, even if I was doing it wrong and just lining up the last number, the last digit, those decimals end up being lined up. Okay, so one of those problems you can do wrong and still get it right. But hopefully you didn't take that 10.9 and then put the 2 over here, because that 2, where's the decimal there? Can't see it? Should I zoom in? No, if you can't see it, it lives to the right. Remember, $2 is the same as $2. If you have to put a decimal somewhere, it goes to the right. Just like if you have to turn a whole number into a fraction, you just put a 1 under it. Okay, so the decimal goes to the right of the 2. I'm going to go ahead and cheat and not rewrite that 10.9 and just add 10.9. So I get 12.9 is my answer. Okay? All right. I said that was the last one, but I lied. I forgot about these ratio problems, right? All right. So recess, peanut butter cups, ratios. Do you eat recess at recess? Is that how you spell Reese's peanut butter cups? I'm not even sure. All right. I think Reese is the name, huh? All right. 40% chocolate, so the rest is peanut butter. What percent is peanut butter? Well, what is the whole thing? The whole thing is 100%, and 40% is chocolate. That means 60% must be peanut butter. Okay? Now, what is the ratio of peanut butter to chocolate? Peanut butter was 60%, chocolate was 40%, so the ratio is 60% to 40 or 60 to 40. Now, when you end up writing that third way, you realize I can simplify 60 over 40 because 20 goes into the top 3 times the bottom. So you're going to say the ratio is 3 to 2. 3 to 2. And you can write it like that. Write it with a colon, you say it the same way, and write it like a fraction, you say it the same way, 3 to 2. You don't say 3/2. Okay? All right. They tried a new candy where they added raisins. Yuck. Okay. And the ratio of chocolate to peanut butter to raisins, it's like chocolate's more on this one, is 4 to 3 to 1. What's the ratio of chocolate to raisin? Well, chocolate was the 4, peanut butter was the 3, and raisins was the 1. So if I'm going to just go chocolate to raisins, chocolate is 4. And see how this is written? Chocolate to raisins. They're asking that question, the ratio of chocolate to raisins. First thing I do is I write that just like they did, and then I put the number underneath, 4 to 1. Isn't that kind of easy? Do it in words first, and then put the numbers right underneath. Okay, because sometimes they're saying ratio of chocolate to the whole thing. Sometimes it's chocolate to peanut butter. Sometimes it's chocolate to raisins. If you have the words, you're a lot more likely to put the right number with it and a lot more likely to get the right answer. Remember, there's 3 ways of writing ratios: 4 with the word to, 4 with the colon and you say to, and the third way is 4 to 1. Okay. And when that second number, the bottom number, is a 1, you have a special kind of ratio. Remember what that's called? You get to pat yourself on the back if you know that's called a rate. A rate is a ratio where the second number or bottom number is 1. All right. Good luck on your Aloha Thursday. Mahalo for listening. That means thank you. We will see you in your Zooms.